Welcome to the Consulting Specifying Engineer webcast, Dynamic UPS Systems, How Kinetic Energy Can Protect Sensitive Processes and Equipment, sponsored by MTU, a Rolls-Royce solution. I'm your moderator, Amara Rozgis, and it's great to be here on behalf of Consulting Specifying Engineer and CFE Media and Technology. Here are some ways to help you get the most from today's webcast. If you're experiencing issues with your slides or with the audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting it on your own computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, click on the question mark on the top right corner of your screen to run some system checks to try before contacting an online technician. If you do need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type questions for our speakers in the Ask a Question box on the left side of your screen. The live Q&A session will be toward the end of the hour. Today's webcast is being recorded, and you'll receive an email within a week to a link of the on-demand version. To download a certificate of completion or a PDF copy of this presentation, use the Event Resources tab on the left side of your screen. These documents will also be available with the on-demand version of this webcast. Now we'll hear from the sponsor of today's webcast event, MTU, a Rolls-Royce solution. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet bleeds. Please stay tuned after the video for today's presentation. All right, thank you. I'm now happy to introduce today's presenters, Niels Gitt and Yves Janssen. Yves has 24 years of experience in the power generation industry, focused on dynamic UPS systems. He is the application sales lead for dynamic UPS large projects and is responsible for sales in India and Belgium. Niels is responsible for global sales, marketing, and business development activities for the company's dynamic UPS products. He joined Rolls-Royce Power Systems in 2011 and has mainly worked in corporate strategy and M&A and on the transformation activities before joining the team at Rolls-Royce Solutions. In his current role, he is focused on growing the dynamic UPS business and setting up sales structure to grow awareness and market acceptance of this powerful technology. Outside of work, he has a passion for soccer and travel. All right, gentlemen, let's get started.
Thanks a lot, Amara, for the introduction, and also welcome to everybody from my side. Let me give you a brief overview of what we are planning to do with you in the next 55 minutes. So I would quickly introduce the MTU Kinetic Power Pack business to you. Then Yves will take over and explain you the working principles of the MTU Kinetic Power Pack. And then in the last chapter, both Yves and myself will guide you through the benefits of our MTU Kinetic Power Pack based on some real-life examples we have executed in the last couple of years around the world. But maybe before we start going into details, let's start with a quick polling question in order for us to better understand how familiar you are already with the dynamic UPS system. So if you could please participate in the poll and suggest if you are very familiar with dynamic UPS systems, if you're somewhat familiar, or if you have never heard of it before. I will give you some time to respond. All right, let's maybe stop here. Let's push the results to everybody so everybody can see it. I think it actually a quite expected result. I think the number of people who are very familiar are rather low. I think the majority is somewhat familiar, but there's also quite some percentage which never have heard of the dynamic UPS technology. So I think it's a great chance that we give you a first intro or insights into our technology. But before going into the technology, let me give you an update or give you an overview of our MTU Kinetic Power Pack business. Basically, Rolls-Royce has acquired the former Keynote business in July 2020. Keynote and now Rolls-Royce Solutions Liège is offering customized dynamic UPS solutions, but not only the system itself, also really customized lifetime service contracts. So in many regions around the world, we also do full-fledged service contracts where we cover all risks for the customer for 5 years, in some regions for 10 years. So this is a huge part also of our offering. The business itself, or the former headquarter of Keynote and now the competence center for the Kinetic Power Pack business, is based in Belgium. There we have around 160 employees, but of course we have subsidiaries around the globe which are taking care of the sales, but also the service. We have right now an installed base of 1,400 units in around 57 countries. I think this already shows that even though it's maybe in some regions of the world a not so well-known technology, I think it shows that also a small business like the former Keynote business was, has really taken the chance to spread the technology around the world. We are mainly active in four different segments: the data center segment, the critical process manufacturing segment, the infrastructure segment, and the healthcare segment. I will talk on the next slide a little bit more about it in detail. But maybe before moving to that slide, let me give you a quick overview of our product portfolio. Basically, the core product of ours is the MTU Kinetic Power Pack unit. There we offer two different product lines: the KP5 unit, which is basically covering a power range from 200 to around 2,640 kVE, and the KP7, which we are mainly using for the higher power ratings. But Yves will explain you a little bit more on the technology itself. On the next slide, you see the various segments we are active in. If we talk about the data center and IT segment, we supply units, of course, to data centers itself. So we have data center customers around the globe. But also, for example, in Saudi Arabia, 2 years ago, we have been awarded a large contract for a supercomputer of the King Abdullah University of Science and Technology. The second segment is at the moment a rapidly growing segment, the critical process manufacturing, because here we are supplying customers from the semiconductor industries, but also customers from the pharma industry, chemical, plastics, textile, many others. If we just look at the top two segments, I think everybody of you has heard about the shortage of semiconductors. So at the moment they are heavily investing. But of course, also in current times with the global pandemic, the pharma industry is also heavily investing. And for example, this year or last year now, we have supplied even some pharma customers for production of COVID vaccination. The third segment we are active in is the infrastructure and logistic segment. So here we are supplying dynamic UPS systems to airports, but also to tunnels, but also especially recently, for example, to logistic centers. So if, for example, supermarket chains have a highly automated logistics centers, that is also very important for them then to have an UPS system. And the fourth segment, the healthcare segment, there we mainly supply our systems to hospitals, but also to research institutes. But now, before going more and more into those segments, let maybe hand over first to Yves to give you a general overview of the technology. Yves, I guess you're still on mute. Yves, you're still on mute. Let's quickly fix that.
Yeah. Is it working now?
Yes, it's working now. Thanks a lot. Perfect.
Okay. All right. Okay, thank you very much, Niels, and hello to everybody. So in that section, as Niels explained, I will go to the working principle of the MTU kinetic power pack. So let's go through it. So some applications require high quality electrical power supply. However, the quality of the electrical grid is not perfect. The grid voltage contains harmonics, spikes, sags. We can have also frequency fluctuation and power outage. This is the reason why we are using interruptible power supplies that's commonly named UPS. And we install mainly the UPS in between the grid and the critical user. The UPS has two functions. It conditions or filters the raw mains before it reaches the critical load. It replaces an absent mains source, ensuring critical loads are unaffected. The MTU kinetic power pack is a combination of a UPS and a diesel generator in one single integrated and compact solution. It looks like a diesel generator that is capable to provide electrical power some seconds, let's say around 15 seconds, after receiving an instruction to start. The MTU kinetic power pack is a dynamic UPS. In case of grid failure, it will provide electrical power to critical load without interruption. It consists in an MTU diesel engine, a synchronous machine, and in between those two, a clutch and a kinetic accumulator. The accumulator is a rotating mass, out of which, in case of mains failure, the energy is taken the time of starting the diesel engine. So let's go now to the second polling question, and if you could answer, at what speed do you think the accumulator of the MTU kinetic power pack runs? At 1000 RPM, 3000 RPM, or 5,000 RPM. So may I ask you to answer to this question? I will wait still some moment that every people are able to answer. So I think that is quite good answer. And what I will do, what I would suggest to do is to continue the presentation, and you will have the answer during that presentation. So let's go to the architecture of the MTU kinetic power pack. On the right side, we have a synchronous machine. A synchronous machine can work in two different modes. If a voltage is applied on the connection box, it works as a motor and it will rotate. If the synchronous machine is driven, for example, by a diesel engine, it works as an alternator and provides electrical power. The synchronous machine of the MTU kinetic power pack is working on those two different modes. When the grid is available, it works as a motor, and when the grid is not available, it works as an alternator. The synchronous machine of the MTU kinetic power pack has two pairs of poles. It rotates at 1800 RPM for the 60 cycle application, like in the US, and at 1500 RPM at 50 Hertz. It is basically a standard synchronous machine, but with a very low impedance. Instead of being coupled directly to the diesel engine, the rotor of the synchronous machine is flanged to the main shaft of the kinetic energy accu. With that architecture, we have one shaft that you see on that drawing on blue that is rotating at 1800 RPM or 1500 RPM, depending if it's 50 cycle or C-cycle application. Around the main shaft of the kinetic energy accu, there is a metallic drum which is rotating. And that metallic drum is represented here in red on the drawing. It rotates at a speed of 3000 RPM, which is the answer of the second pooling questions. We usually name it as the accu. Because of the rotating mass, we have kinetic energy that is stored on that accu. When it's retried, that kinetic energy will be transferred to the alternator by making an induction coupling between the accu that you see in red and the main shaft that you see in blue. At the end of the shaft of the kinetic energy accu and before the diesel engine, there is an electromagnetic clutch. It is constituted by two plates, and its closing or opening is operated by the control system of the MTU kinetic power pack by energizing or not its coil. Now, let's talk about the single line of the MTU kinetic power pack. The unit works in combination with a switchgear, the power panel or the POP. It is equipped with one input circuit breaker, the QD1, one output circuit breaker, the QD2, one automatic bypass switch, the QD3. It includes also a choke or reactor, we could name it also, that makes the segregation between the input and where the grid is connected and the output where the critical load is connected. The synchronous machine is electrically connected at the end of the choke. In conditioning mode, QD1 input breaker and QD2 output breaker are closed. QD3, the automatic bypass breaker, is open. The active power is supplied from the mains. The synchronous machine is running at 1800 RPM for the 60 cycle application. The accumulator is rotating at 3000 RPM. The clutch is open and the diesel engine is stopped. At this stage, the dynamic UPS improve or conditions the quality of the voltage that is available from the grid to provide a high quality power supply to the critical load. The combination of the choke and the low impedance of the synchronous machine acts as a dynamic filter and makes the power factor improvements. In case of mains failure, the dynamic UPS will switch from conditioning mode to independent mode. And how is doing that? Simply by giving instruction to open the circuit breaker QD1. At this stage, the accumulator, the accu, will maintain the frequency, so the speed of the main shaft. The diesel engine starts and the clutch closes. We have a smooth transfer of the power supply with high quality interruptible power supply provided to the critical load. I'll go too fast. During the time that the mains is not available, the MTU kinetic power pack is on independent mode. During this working mode, the diesel engine provides the power to the load. The kinetic energy is stored back by increasing its speed. Once the power outage is resolved, we have a synchronization across the circuit breaker QD1, the input circuit breaker. And if the accumulator has reached its nominal speed, QD1 closed and the clutch open. Diesel engine will run at idle speed for cooling down, and then it will stop. The dynamic UPS, the MTU kinetic power pack, is back on conditioning mode. And then we have again a smooth transfer with the high quality interrupted power supply provided to the critical load. The dynamic UPS secure the load against, which is very important, an unlimited number of repeated mains failure. So let's go to the section 3, and we will start that section 3 with Niels.
Yes, happy to take over again. Let's talk a little bit. I think we now heard a little bit of theory. Let's now go and talk a bit about the benefits of our solution based on some examples we have around the world. When I started to work, especially for this dynamic UPS business, and Amara mentioned that I'm working for Rolls-Royce now for around 10 years, and then just transitioned to this business beginning to mid of last year. I was asking, basically all the technicians and the sales people on what are really the benefits, especially compared to a static UPS. And everybody loves the solution, and I think they could tell me for hours on what the benefits are. But let's maybe summarize it a little bit in the 5 main points. I think as Yves has explained, it's a very simple design with a limited number of components. And of course, this really helps to maximize reliability. It's a very, very reliable system, and we could prove that with the installations we have around the world. The other benefit of this design is that it's a very compact footprint. If we compare it to some of the static solutions, we can save 30 to 40% of the space. I know that in some applications, in some areas, this doesn't really matter that much. But if you build a data center in the middle of London or in Singapore, space is a very valuable good. And of course, our customers rather use that space in order to rent it out or basically equip it with racks than to just use it for the static UPS. When it comes to cost, I think in general, openly talking about it, I think if we just talk CapEx, we will have hard times to compete with static UPS, depending on the specifications of the solution. However, if we talk about total TCO, I think we have a very, very attractive solution, and we can easily win against static UPS solutions, especially at medium or higher power ratings. Because our solution has a very long lifetime. Basically, we need to do an overhaul after an overhaul after approximately 10 years, where we have to do only change overhaul certain components. Whereas, for example, static UPS solutions need to change the batteries depending on, of course, the battery technology, every 5, 8, 10 years. One of the other great advantages is the flexibility we have. So you can have a low or medium voltage system. You can have also a fully containerized solution, where basically our compact system is all in a container, very compact, easily mountable outside of the building. And of course, one other advantage is the sustainability. Our solution compared to static UPS, of course, eliminates the batteries, and in general, our solution has a long lifetime. As I said before, every 10 years an overhaul. But if you do the proper maintenance and if you do the overhauls, our systems, and we can back that up with the right examples, easily lives more than 25 years out in the field. Let's look at some examples, and we brought you 4 examples today, 2 from the Americas, 1 from Europe, and 1 from Australia. I will always give you a little bit of insight on what did the customer need there, and then Yves will explain you a little bit the technical solution we have applied for that customer. Let's start with the example from Europe. There we have basically had a project with Bayer Healthcare, who should be very familiar to all of you. Bayer basically was building a new pharmaceutical filling line for a new drug they have developed. And for them, one of the key priorities, of course, was to keep the laboratories sterile and to protect the system. In our first discussions we had with them, it became very obvious that if they ever face a power outage, they basically would lose the production volume of 5 to 6 weeks, which of course would be significant cost to them, but also would of course endanger promises to customers when it comes to lead times, etc. So the reasons why they have chosen our system is, one, the filtering and power quality improvement. Second one is, of course, that with our system, they can avoid any financial losses. And the other more technical point is the ability of our system to deal with high inrush currents. But maybe Yves, you can elaborate a little bit on the technical side. If we go to the next slide, I will quickly do it.
All right. Thank you, Niels. So at this project at Bayer, which is located in Leverkusen in Germany, we made a turnkey installation inside a building of one MTU kinetic power pack KP7 of 2500 kVA at 400 volts and 50 hertz. This is a single unit, and we have an electrical topology with a power panel equipped, just as I mentioned before, with QD1, QD2, and QD3, as well as the code that made the segregation between the electrical grid and the critical loads. So this is exactly as I explained, the topology as I explained just before. So we could switch to the next example now.
Yep, let me take over here again. Next example is from Brazil. Actually, one of our biggest customers around the world, Ascenty. Ascenty, if you haven't heard of them, is a big data center provider in Brazil. And we have right now approximately 100 units with them installed in Brazil. So this is only one example of many data centers we have worked on with Ascenty. I think Yves just talked about that we have equipped basically the Bayer unit inside a building. Ascenty is a perfect example of how we can also basically put all of our units into containers. So on the small picture on the left side, you see the data center. And then in front of the data center, you basically see our 9 dynamic UPS units standing fully containerized. The one Ascenty, because of their importance for us as a business, basically they were one of the first customers I talked to when I joined the company. And my question was, why do you prefer our solution? I think for them, really the key points are the ability to fully containerize it, the reduced footprint, so basically the space saving they can achieve with our solution, but also the low total cost of ownership. They are always looking with their investments at what does it cost me over the next 5 to 10 years, and they always do the comparison with static technology versus dynamic technology, and they are in many cases in favor. But the other point also, which was for Ascenty one of the most critical points, is which is not even on the slide, is our service delivery. If we have big customers, if we have big sites, we always make sure we also have a resident technician basically at site, who is 24/7 covering their operation, taking care that everything is functioning. I think our solution in general is an insurance for all our customers. So of course, we also on a service side want to make sure that we ensure the customers that our solutions are running perfectly. But let's maybe look at the technical side of this project.
Yes, Niels. So for that project, we have at that side of Ascenty in Hortalandia, we have 3 power stations. So each of those power stations consists in 3 single and totally independent dual output MTU kinetic power pack, KP5 of 2250 kVA, working at 400 volts and 60 cycle. And as Niels mentioned, all the MTU kinetic power pack are installed in container outside of the data center. So, as I just mentioned, it's a dual output dynamic UPS. And what is a dual output dynamic UPS? Is a system that is capable to protect two types of loads. The critical loads that require high quality power supply, and essential load that can accept an outage of their power supply for a maximum of time of 15 seconds. At Ascenty, this is a data center, the critical load are the IT rack, the IT loads, and the essential load are the mechanical loads like the chillers. At Ascenty, the topology is a distributed redundant in the N plus N configuration. Is a tier 4 configuration. The key feature of a distributed redundant topology is that the distribution of the dual corded critical load, the IT rack that are dual corded, through independent as and separated dynamic UPS units. It allows to achieve N plus N redundancy with a UPS unit that can be loaded at a higher level than 50% of their nominal rating. And as at Ascenty or Talandia, each of the power stations we have 3 independent dynamic UPS, we can load each dynamic UPS up to 60% of their power rating that will protect the load with a N plus N redundancy. So it's basically the topology of the distributed redundant with totally separated single and independent dynamic UPS. So let's go to the next one.
Yep, happy to take over again. The next example is an example from the logistics center, a big supermarket chain in Australia. Unfortunately, I cannot disclose the customer name. Basically, the customer has built a really big, new, fully automated warehouse with latest state-of-the-art automation technology. And because of this high automatization level of the warehouse, for them, it would basically take several hours to even days to restart and recover the system fully in case they would face a power loss. That's why they were urgently looking for an UPS system. We had good discussions with them. We've also done now the second project with them. I think, yeah, very similar to the previous examples. I think reduced footprint for them was a very important point. Of course, to have us as insurance versus any financial loss they could face based on a power loss. The other main aspect why they choose us was a fast fault clearing capability of our system. And with that, Yves, I would hand directly back to you to explain our technical solution.
Thank you, Niels. So this project in Sydney consists in the installation of 4 MTU kinetic power pack KP5 of 2000 kVA at 415 volts and 50 Hertz that are working in 2 parallel. And the configuration that we have here, it's an isolated parallel configuration in an N+1 redundancy. So here, what was the challenge? If we want to place 4 UPS, dynamic UPS of 2000 kVA into parallel, we will reach a fault level that can exceed the short circuit withstand of the switchgears. So the fault level of 4 dynamic UPS of 2000 kVA will be above a fault level of 120 kA. That means that we have limitation on low voltage of the number of machines that we place into parallel. And this limitation is not due to the technology of the dynamic UPS, but the technology of the switchgear that is available on the market. So, and how we solve this challenge of the short circuit is by placing downstream close to the paralleling bus. You see that there is a bus, but which is in fact a ring, but in the single line diagram, in the bottom of the single line diagram, we have a ring, which is a paralleling bus. And each machine is connected to this paralleling bus through a choke that will limit the short circuit contribution of each machine. So that is a way of solving the problem of placing the machine into parallel by keeping the fault level in a reasonable level for the switchgears. And this installation, this type of installation, we are doing quite oftenly where we need to have N+1 configuration. To you, Niels.
Okay, then let's end with one example from the US. Here we have equipped a highly advanced semiconductor plant of Global Foundries in upstate New York, close to in Malta. I think for this example, one of the solution besides the ones we have already talked about in the past couple of slides is really the medium voltage capability of our system. And Yves will guide you now through the single line diagram on how the configuration looks like.
Okay. There we have also parallel system. We have in fact 2 independent power stations of each of 6 MTU kinetic power pack, KP5 of 2000 kVA, working at 13,800 volts at 60 cycles with N+1 redundancy. So as I mentioned before, the challenge when we place parallel system into parallel is the fault level. So that's challenge could be solved with an IP bus, as I just mentioned, with a choke to reduce the fault level contribution of each machine, or to work into medium voltage. So here we choose the second solution. We work into medium voltage. We could have a low voltage alternator with a step-up transformer, or we could have directly a medium voltage alternator. So this is the configuration that we have at Global Foundry. And what we have done in addition, as is a 2 power station that of 6 no-break working at N+1 configuration, we have in addition the possibility to couple those 2 independent power stations in order to have 1 power station at 12 dynamic UPS working into parallel. And the main purpose of this is to be able to keep the redundancy N+1 even if we have stopped 1 machine on 1 of the power station. So we keep in this stage the redundancy N+1 by making the coupling of the 2 power station of 6 no-break in order to have a power station of 12 no-break or 12 MTU kinetic power pack.
Thank you, Yves. I think
Niels.
with that, we are already at the end of the presentation and basically perfect in time. Maybe let's just do a quick summary and before we go into the Q&A. I think we have shown in the presentation that our solution can deliver benefits to a high variety of applications. We have demonstrated around the world with more than 1,400 units that our solution works. Yeah, and with that, basically, I'm, of course, looking forward maybe in future to work with some of you to protect additional sensitive processes and equipment in the Americas. But maybe let's first use in the next 15 minutes really the time for Q&A. With that, Amara, I guess I hand over to you.
Yes, excellent. Thank you so very much. And now these presenters will answer questions from the audience. Please type your question for the presenters in the Ask a Question box on your screen, and we'll get to as many questions as time allows. Questions that we do not get to today will be posted online at www.csemag.com with the archived version of this webcast. And remember to download a certificate of completion or a copy of this presentation. Use the Event Resources tab on the left side of your screen. All right, Niels and Eve, we have quite a few questions here, so let's get started with these. First question, do these MTU kinetic power packs need to be mounted indoors, or are they available with outdoor weather or sound attenuating enclosures?
Answer, Niels? Yeah, okay.
Yeah, you go ahead. All good.
No, go ahead.
No, I think we've shown in the presentation that basically we have both solutions. I think, of course, we have indoor installations, but for example, the example of Ascenti, the data center in Brazil, shows that we also have fully containerized units. Not only in Brazil, we have them around the world, also in Middle East, somewhere in severe weather conditions. We also have container solutions basically in the Atacama Desert in Chile at 2,500 meters height. Yes, you can have both indoor installations, but also containerized solutions.
Okay, thank you very much. Next question for you. What is the lifespan of a dynamic UPS in comparison with a regular UPS?
I will answer to it if you want, Niels.
Yeah, go ahead.
Mainly the lifetime of a static UPS is 10 years. So after 10 years, it's great time to think to replace the static UPS. If we use also VLRA batteries, those batteries has to be changed after 5 years. 8 years. It depends how you maintain the batteries. Now, our system, the MTU kinetic power pack, has a lifetime of more than 25 years. We have installations that are still working at the full satisfactory of the customer that is more than 25 years. Mainly, we have to change the bearing after a period of 10 years. So this is the larger maintenance that we have to make in our system on the MTU kinetic power pack. It's to change the bearing after 10 years. After 10 years, when we have changed the bearing, the system is ready to protect the load for 10 additional years.
Great, good to know. Thank you, Eve. Next question for you. What is the approximate efficiency of the system during conditional mode?
It's a good question. It's the most important efficiency that we could have. It's on the conditioning mode, because 99% or 99.99% of the time, the MTU kinetic power pack will run on conditioning mode. And it depends of the power rating, but for the larger machine, we could go up to 97%. But what is very important to take into consideration is not only the losses between the input and the output of the UPS, if I could say, but also what you need in addition to let work the system. In our system, on the MTU kinetic power pack, we do not need air conditioning. So with this system, the MTU kinetic power pack, to cool the system, we need only forced ventilation by fans. So comparing to the static UPS, mainly we place the static UPS on a white room on which we need chiller and air conditioning. So there we have additional losses.
Very good. Thank you.
Yeah.
The next question, what kVA sizes are available for these kinetic energy sources?
Yves, go ahead.
Okay, so we have from 200 kVA, the smallest machine, up to 3000 kVA on 60 cycle. So for the larger machine, we are using the MTU 20V4000 diesel engine. So from 200 as a single machine, 200 kVA up to 3000 kVA.
Sure. Okay. Thank you. The next one for you is, after a mains failure, how much time is needed to recharge the accumulator at full system load?
Okay. At full system load, so this, as soon as there is a mains failure, if you remember the presentation, we open the circuit breaker D1, the diesel engine is started. And the system, the MTU kinetic power pack, will not wait that the diesel engine, that the grid is coming back. It will recharge the accumulator with the diesel engine. So it could be that when the grid is coming back, if it takes a time of 20 minutes, for example, when the grid will come back, the accumulator will be already fully charged. Typically, between the time that if we take all the energy that is stored on the accumulator, typically it will take around 15 minutes to charge the accumulator. But the system is not waiting that the grid is returning in order to start to charge the accumulator.
Okay, got it. Thank you. And the next question, which US EPA emissions tiers are available for the diesel engine?
I'm not fully familiar on it. I think that's EPA tier 2, but Niels, you could perhaps, or
Yeah,
Brian.
I think also not an expert on EPA emission certificates, but I mean, we are part of MTU or Rolls-Royce, and MTU is with the brands active with the gensets in all of the US, and we also fulfill all emission certifications in the US. Yeah, but otherwise, happy to come back to you with a detailed overview.
Sure, we can come back to that one in writing. Thank you. All right, what type of maintenance is required for this system?
All right. So, first of all, the system, as I explained, is a combined system with the diesel engine, a synchronous machine, clutch, and the kinetic accumulator. The maintenance that is required on the diesel engine is the maintenance on the MTU diesel engine, is the maintenance typically that is used on the diesel engine, and typically, and we have to make the change oil. We have some maintenance to be done, but it's typically the maintenance of the diesel engine. Regarding the UPS part, so the dynamic UPS part, we have to, the system must be greased, and we have automatic greasing system that we could place. So normally, if we do it manually, we have to make the greasing of the bearing every 2 months. But if we do it automatically, it will be done continuously. In addition, so as I mentioned, we have every 10 years, we have the system must have an overhaul on which we will change all the bearing of the alternator and as well as of the accumulator. So this is basically, in the short words, how the type of maintenance that has to be performed on the MTU kinetic power pack.
Great. Thank you, Yves. If you do have questions, we have time for just a couple more. Please type your question for the presenters in the Ask a Question box on the screen. And questions that we don't get to right now, we'll answer as many as possible in writing. All right, next question for you. Let's see here. Will units running on natural gas or other clean fuels be available in the future? Gentlemen, if you'd like to pull out your crystal ball, that would be great.
No, I mean, I think it's a very, very good question and a very important question with all the discussions we have currently. So in general, the plan is yes. We are looking at the moment at first natural gas, especially as a bridging technology. However, for our technology, it has some challenges. But then, of course, we are also looking at running basically on hydrogen. So I think we are doing with our R&D team at the moment a lot of research on those topics. We have gas engines from MTU in the portfolio. We will also have hydrogen engines based from MTU in the portfolio. And now I think it's up to us to really see how can we match that best with the accumulator and the synchronous machine and come up with a kinetic power pack based on those technologies. But openly speaking, we are still in the evaluation phase and currently looking at the options and, of course, the business case as well for the various solutions. But, of course, there is an intention clearly to go more towards new technologies.
Right, right. Sure. Okay. Next question for you. What's the difference between KP7 and the upper end of the KP5 range? This person noticed some overlap between the two.
No. Yves, go ahead.
Yeah, exactly. It's a new version of the MTU kinetic power pack. The KP7 is a new version. KP5 is a previous design. We use it for the larger machine. The main difference of the KP7 comparing to the KP5 is that the cooling of the synchronous machine is done by electrical fan. So we could control the power that is used in order to cool the synchronous machine, while on the KP5 we are using the mechanical fan that is fixed on the shaft of the synchronous machine. The second main characteristic of the KP7 is that the system could run continuously for 10 years and before stopping at all the machine for making the maintenance of the dynamic UPS. So the the accumulator is also to accept also automatic greasing that JP5 cannot. That's the main difference between the two technology.
All right. Well, thank you for that information. And thank you to both of our presenter, Yves and Niels, for sharing your time and expertise today. That's all the time that we have. So I'd like to extend a special thank you to our sponsor, MTU, a Rolls-Royce solution, for sponsoring today's event. And now that we are just about done, we want to know how we did. An exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, I'd like to thank you for attending. This now concludes our webcast. Thank you and goodbye.